So here is another question on simple harmonic motion. So it is given that the time period of a particle executing simple harmonic motion SHM is 2 seconds, and it can go to and fro from equilibrium position at a maximum distance of 5 centimeters. If at the start of the motion the particle is in a position of maximum distance or maximum displacement towards the right of the equilibrium position, then write the displacement equation of the particle. Okay, so now, like all the questions that we have solved previously, first step is writing the standard equation of simple harmonic motion. This. Now, here A is the amplitude, maximum displacement or maximum distance covered by the particle from the mean position either side. Omega is the angular frequency in radians per second, phi is the initial phase angle in radians, and t is the time instant, particular time. Now it is given according to this question that for the SHM motion here from the mean position or the equilibrium position, let it be here, on either side the maximum displacement is how much? 5 centimeters. Okay, 5 centimeters. Here also 5 centimeters, but here it is negative. So here amplitude A is equal to 5 centimeters. Then it is given that the time period T, that is equal to 2 seconds. Time period is equal to 2 seconds. So we know that angular frequency omega is equal to 2 pi f, where f is the frequency in hertz or second inverse, or we can write it as 2 pi 1 by t, 1 by time period, because frequency is the reciprocal of time period. So that implies t is equal to 2 pi by omega. Okay, 2 pi by omega t. So here if we put the value, then omega will be equal to 2 pi by t. Here time period is equal to 2 seconds, so it will be 2 pi by 2, that is equal to pi radians per second. That is the angular frequency. So we have got the angular frequency, we have got the amplitude, now we have to get the initial phase angle. Then another piece of information, vital information which is given is that at the start of the motion, that is at t equals to 0, the particle is in a position of maximum displacement towards the right of the equilibrium position, which means that at t equals to 0, the particle is located at maximum displacement position towards the right side here at t equals to 0. It means that the position of the particle at t equals to 0 is equal to 5 centimeter. So here if we put this in this SHM equation, where y is equal to 5 sine pi t plus phi, here if we put y is equal to t equals to 0, which is equal to 5, then that will be 5 sine pi into 0 plus phi. That implies 5 sine phi is equal to 5. That implies sine phi is equal to 5 by 5, which is equal to 1. That implies phi is equal to sine inverse of 1, which is equal to how much? Pi by 2 radians. So the initial phase angle, this is equal to pi by 2. So now we have got the amplitude. Okay, here we have got the amplitude, the angular frequency and the initial phase angle, all the parameters required for writing the SHM equation. So here the SHM equation of this particle will be equal to y is equal to 5 sine pi t plus pi by 2, or we can write it as 5 sine pi to t plus 1 by 2. This is the SHM equation. Okay, so every piece of information which was given in this question, we used it to determine the various parameters. Okay, first starting with the maximum distance, we got A. Then using the time period, we got the angular frequency. Then using this information that at the start of the motion the particle is in a position of maximum displacement towards the right, we got the initial phase angle. Okay, so this is the thing. So here is another question on simple harmonic motion. So it is given that in what time after its motion begins will a particle oscillating according to the equation, the SHM equation, displacement equation given by y is equal to 7 sine 0.5 pi t move from the mean position to the maximum displacement. Okay, so here if we compare the given equation with the standard SHM equation format, if we compare this and y is equal to 7 sine 0.5 pi t, then we'll find here A is equal to the amplitude or maximum displacement, that is equal to 7, okay, this much. Then we have the angular frequency omega, that is equal to 0.5 pi or pi by 2 radians per second or whatever units which is used, and the initial phase angle, that is equal to 0 here. Now it is given that the particle oscillating according to this equation, it will move from the mean position to the maximum displacement. So it means the position of the particle is equal to the maximum displacement or amplitude, which is equal to 7. This is the required condition. So here we'll substitute this in this equation. So 7 is equal to 7 sine 0.5 pi t, or we can write it as 7 by 7, taking 7 to the LHS side, that is equal to sine pi by 2 into t. That implies sine pi by 2 t is equal to 1. Now here we have to express this RHS in a form, in sine form, in order to equate these two. So sine pi by 2 is equal to 1, so we will write sine pi by 2 into t is equal to sine pi by 2. That implies t is equal to 1 second. So at t equals to 1 second, the particle will move to the maximum displacement position. Okay, this. So a good question, basic question, from which we have to read the question properly, to use the different terms that is given and putting the respective values in the respective positions to get the desired result, the desired value of the parameter which we got. Okay,